Arun sir.
Yes, sir. Yes, sir. Shall I
Sir.
proceed?
Yes, sir.
Well, good evening to one and all. It's my pleasure to invite you all for the 84th webinar in series of the Engineers Talk, a weekly online lecture series being organized by IEI Salem Local Center in commemoration of its 30th anniversary celebrations. I would like to request the chairman of IEI Salem Local Center to welcome the guests and the gathering. Please, sir.
Yes, sir. Thank you, sir. Respected today's chief guest, Engineer Vasant sir, beloved keynote speaker, Engineer Jairupan sir, beloved Honorary Secretary, Dr. C. Daumani ma'am, Armugam sir, members of both IEI Salem Local Center and Tamil Nadu State Center, engineers, stock team members, fellow engineers, friends, students, and our IEI office staff, Mr. C. Thiago. Good evening to one and all present for this again wonderful occasion. On behalf of the Institution of Engineers India, Salem Local Center, I extend my warm greetings and a heartfelt welcome to each and every one of you to the 84th special webinar under our weekly online lecture series, Engineers Talk, held under the aegis of today's program under the aegis of Aerospace Division Board. As we proudly commemorating the 30th anniversary of IEA Salem Local Center, it is indeed a privilege to host this special session that reflects our continuous commitment to knowledge dissemination, professional development, and also engineering excellence. We are truly honored to have with us today our great supporter and friend, Engineer Vasant Murugan sir, founder and CEO of NITA Aerospace Private Limited Salem, as our chief guest and keynote speaker. Sir, your entrepreneurial journey and contribution in the aerospace sector are an inspiration to all our aspiring engineers and also innovators. We are equally pleased to welcome Engineer K. Jairupan, Engineer Quality from Sir's team, who join us as a distinguished speaker today. The topic of today's webinar, aerospace material, is again highly relevant and timely, especially as India continues to make significant advancement in indigenous aerospace technology and defense innovations. We look forward to gaining insights from uh, both of the expertise on this critical role materials play in the design, performance, and also safety of aerospace components. I take this opportunity to appreciate and thank all the enthusiastic participants who continue to support and engage in our weekly knowledge sharing initiative. Your consistent participation is what makes this platform vibrant and also meaningful. Let me also remind everyone that IA members with the highest participation across sessions will be honored during our Engineers Day 2025 celebration. Also, I would like to extend my sincere thanks to um, the engineers talk team members, organizing team, our beloved honorary secretary, engineer Armugam sir, and IE staff Thiago. Also, each and every technical coordinators and contributors for their tireless effort in making this session possible every week. Once again, a warm welcome to all of you. Let this evening be a fruitful and enlightening experience for everyone. Thank you.
Thank you, sir. Now it's my pleasure and privilege to introduce the chief guest of today, Mr. Vasant Murugan, founder CEO of NITA Aerospace Private Limited. Engineer Vasant Murugan holds a bachelor degree in mechanical engineering and a master's degree in manufacturing engineering and MBA to his credential. He has served as the CEO of Salem Material Technology for over a decade. Mr. Vasant Murugan is a partner at Endotherm Technologies and serves in several other influential roles. He is regional coordinator of the Bridge Bharat Council. He is secretary of ASM International Salem chapter and secretary of the Karupur Sikko Women Industrial Park Association. He is advisory board member of Directorate of University Industry Collaboration DUIC at Periyar University Salem and member of Internal Quality Assurance Cell IQAC at Government College of Engineering Salem. With these words of introduction, I would like to invite Engineer Vasant Murugan to address the gathering. Please, sir.
Good evening, everyone. Am I audible?
Yes, sir. Yes.
Thank you. Thank you for the brief introduction, Mr. Arumugam, sir. I am really happy to be part of 84th IEI Engineer Talks. Really proud to be here and sharing my experience and introducing our dream startup journey. Thank you, congrats, sir, for taking this, giving us this opportunity to share our experience with you and with all the engineers. Uh, Nita Aerospace is private limited is 1 year startup. We are into aerospace, defense, oil and gas industry, fasteners manufacturer. Uh, 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 Fasteners manufacturer. Right now, we have completed one army audit from BRD 5, waiting for the approvals. Uh, this is our recent achievements, and we also started participated in international defense expo at Jodhpur last year conducted. With all this experience from the heat treatment industry, I am from heat treatment family. My father into heat treatment for 30 years. We have units in Salem and Coimbatore. The mother unit is in Salem, still in working. From there, I have started my dream that my patriotism to support our nation. Why I choose fasteners for my as product? It's a completely metallurgical product, which has most complicated and critical area of metallurgy to supply. We are planning to supply from melting to plating, the complete process in Salem. And happy to announce that we are going to be the first core company going to be in Salem, that we are starting 4.4 industry in coming year. And coming to the today topic, that aerospace materials, we all really think that composites have more values and more inquiry, more requirement in aerospace sector. It's really not like that. Still, steel and aluminum, copper as a tremendous requirement in the aerospace industry. Uh, uh, my colleague will share you the details with the metrics in coming talk. And I like to tell that in defense export in 10 years, recent 10 years, India started around back to 10 years, it's all about 686 crores. Now, due to indigenization process and make in India, it has increased by 2,973 percentage. The last year ratio will be 21,000 crores yearly exported from India. It's a biggest opportunity. And then coming to in production in India itself, it's nearly about 46,000 crores in last 10 years in 2014 to 15. Now coming to 2023 and 24, it's around 1 lakh 50 crores. In upcoming year, it will hopefully, we are expecting it will come to about 200 or 300 percentage hike, because most of the components are compulsory. Plan Our government and defense asked us to make in India itself only. where inconel titanium, aluminum alloys, magnesium, and then copper based and uh, duplex stainless steel, which has more requirement in aerospace. It will be briefly delivered by my colleague Mr. Jairoban. Once again, I thank Tangaraj sir and Armugam sir and Thiagu sir for the wonderful opportunity to be the part here. Thank you.
Thank you very much, sir. Thank you for briefing your journey in making materials for aerospace engineering. And now it's my pleasure to introduce the keynote speaker and colleague of yours, Engineer Jairuban K, Engineer Quality at Nitha Aerospace Private Limited. He has completed a bachelor's degree in metallurgical engineering at Government College of Engineering, Salem. He began his professional journey at PK Steel Castings Private Limited as a graduate engineer trainee in the research and development department. His work focused on melting processes, metallurgical testing, laboratory analysis, root cause investigations, and failure analysis. Currently, he is responsible for overseeing and managing special processes and ensuring compliance with
with
standard
standard
and
and
continuous
continuous
improvement.
improvement.
With these
With
words
these
of
words of
introduction, I
introduction,
would
I'd
like to
like to invite
Engineer K.
Engineer K.
Rupan to
Rupan to
present on the
present on
topic
the topic
aerospace material.
aerospace material.
Please, sir.
Please, sir.
Sir, audio
Sir, audio
இது ஓபன் பண்ணல.
Now I am audible, sir.
Yes, sir. Now you are audible.
Yes, sir. Thank you, sir. Once again, I thank IEM for this opportunity and Mr. Armugam, sir, for the brief introduction. Uh, uh, so we can let move into the topic aerospace materials. Uh, in aerospace materials, we have a lot of know about the aerospace materials, which are complicated, which are highly precise manufactured by highly precision manufacturing methods. Let's go into brief about the aerospace materials. What are the materials what we are using currently, and what will be the future scope of these materials? uh, for introduction, I selected why how we choose the aerospace material. The material selection is an important role in the aerospace industries because the material should be sustained in the harsh environment and high pressure conditions and high temperature conditions. For that, we are using the high alloy steels and some alloy steels and inconel metallic materials and non-metallic materials. In metallic materials, there are a lot of materials we have used, and the future is going to be non-metallic materials, which is composites. The composites are based on aluminum and other other things. In the particular view of composites, it's not it's the aerospace industry is not completely depending on the composites materials only, but it is currently are also seeking the metallic materials. And that is the part of which I'm going to deal with in this seminar. In this seminar, I'm going to talk about only metallic materials. Yeah, we all know materials which has a high density will have an high weight. If weight of the materials and the weight of the components will increase in the flight, the fuel consumption will starts to increase. If we want to reduce the fuel consumption and efficiency of the flight, we need to reduce the weight of the components. For that only, they are choosing the low weight and high strength materials. Let's go on deep into this. First of all, I want to compare the aerospace materials with the automobiles material, which are conventional materials which are a lot of use in day-to-day lives. Just go into this. First, the primary objective is presentation. Sir, is my screen is visible, sir? Yeah, yeah. Visible, yeah, presentation. Presentation. Share from there, screen share.
No,
Screen,
sir.
screen you should PPT.
No, sir. Your screen is not visible.
Yes, I will check. On the PPT one. Sir, now it is visible, sir.
Yes,
Yes,
sir,
sir.
visible.
Yes.
Sir, make it full screen, sir.
Sir, I'm in full screen mode only, sir.
Screen, now you make it full screen.
Okay, go ahead. Go ahead, go ahead. So for now it is visible, sir.
Sir, visible,
Yes,
sir.
sir. Yes.
Yes, sir. Thank you, sir. Thank you for the confirmation, sir. Uh, First, I want to compare the aerospace materials with the convenient or automobile materials which we are using for the automobile applications. The primary objective of aerospace in this aerospace material is high strength and fatigue life and thermal stability. Fatigue life is an term which is used in metallurgy. It denotes the cyclic load, the material reactive reaction or the nature of a material when it is low comes through the cyclic load. For an aerospace materials, it should be an higher. Automobile materials, it's not need that much of amount of fatigue life. The alloy systems used for the aerospace materials are titanium, nickel based, and aluminum based alloys. For in automobile industries, it is not like that. They are using low carbon steels, low alloy steels, and HSLA, high strength low alloy steels. These are basic and convenient materials are using. The processing techniques are also variant from the aerospace and the automobile sectors. The melting and the root of the casting process in aerospace is very highly precision to control the inclusion rating, which directly affect the material properties and the working uh, working properties. But in automobile industries, there is no restriction for the inclusion in that much what we are expecting for the aerospace. For taking a microstructure, it is very crucial in the microstructure. In the liquid state, from the liquid to solid, it should be an columnar or equiacid grind growth. These are the parameters should be controlled for an aerospace industries materials. Then surface engineering, the PVD, physical vapor deposition, chemical vapor deposition, short printing techniques. These are the techniques that are required to improve the surface of the aerospace materials to avoid the fatigue, to avoid the failure due to the fatigue, corrosion. The cadmium plating is used in aerospace materials to enhance its corrosion resistance in an harsh environment. But in our automobile industries, they are using a nitrating, carburizing, zinc plating for the conventional galvanizing as like a conventional surface treatment to avoid the wear resistance only, to improve the wear resistance only. And the temperature range for an aerospace material, it should be from cryogenic temperature to 1000 degrees Celsius. If the flight travels in a cryogenic temperature, it should be, the material should be withstand its nature. And when it is used in jet engines, it should be always should be in sustainable for that particular environment. But the automobile industry not will go to an up to 1000 degrees, or not go to the cryogenic temperatures. Historical evaluation. Yearly, in the first yearly before the World War, when an aircraft was manufactured, they used timber, woods, and fabric for the construction. It's Then in 1920s, the evaluation of aluminum is emerged in the aerospace industries. Then now it's moved to titanium and super alloys. Whenever the materials are choosing and the design of engineering involved in an aerospace materials are the nature and working principles of the materials what we are going to choose is considered as a primary point. Then it is designed as per the requirement. Then it is manufactured by advanced and computational techniques. What are the challenges we are facing during the selection of right material for an aerospace industries are extreme temperature resistance and corrosion and environmental durability, fatigue and sustainability consideration. Extreme temperature resistance, as I already told, the temperature may be gone up to cryogenic temperature to 1000 degrees Celsius. The material should be withstand these temperature. If you know about the Titanic the ship was broken due to the DPDT. The term used in metallurgical is ductile to brittle transition temperature. When the material goes below to the transition temperature, the ductile material will transition into brittle material. What I try not to say means the ductility, the elasticity of the material started to lose, and the material will become as a glaceon, which leads to a sudden failure or broken. When the temperature increases, the hardness, the strength will lose. These are for these things we will choose an appropriate material for the to sustain this temperature. And then corrosion. The material should have withstand the corrosion resistance, the corrosion, general corrosion, pitting corrosion, galvanizing corrosion, and stress corrosion cracking. These are the common corrosion types that are facing in the aerospace industries. These and the corrosion should be avoided while we are choosing the right material. And then fatigue loading. I already told fatigue is a cyclic load. The material should have a capacity to meet the to withstand while the cyclic load is occur. The properties, the general and most important properties in for an aerospace materials are strength, toughness, and thermal expansion. Strength, we all know, strength is defined as the resist to deformation. When an force externally when a force externally loaded on the material, the deformation should not occur. That is called as strength. And toughness is an ability of material to absorb the energy while it is plastically deformed. And thermal expansion, the material should not expand to the thermal means heat and other factors. Here I show the typical material distribution of a jet engine. For this is a jet engine, cross section of a jet engine. For fan they are using titanium alloy. Low pressure compression they are using titanium or nickel alloy. High pressure compressor titanium or nickel alloy. Combustion chamber nickel alloy. High pressure turbine nickel alloy. Low pressure turbine nickel alloy. And for casing they are using aluminum alloy. Accessory section they are using iron or aluminum alloy. Turbine blades are made with a nickel alloy. The exhaust case is made up of nickel alloy. These present the wide range of materials used in a turbine jet engine. The selection are based on the parameters which I already told: environmental, that is corrosion resistant and fatigue life, and temperature withstanding characteristics. Aluminum alloy. The commonly used aluminum grades are two series. The grades are 2024, 3003, and 5052, 6061. These are widely used in aerospace industries. They are mostly used in the fuselage structure, wing components. A structural application is used by the aluminum parts. The reason behind the choose aluminum is its weight to strength ratio is too good. It has low weight, but it has a good strength. That is the ideal reason for choosing aluminum for an aircraft construction. And titanium alloys. TI6L 4V, known as in grade 5, offers a balanced strength and ductility more than an advantage when compared to steel. It has better off and percentage of density. What it means, the weight of the weight of the titanium is more less than the titanium. Sorry, weight of the steel is more greater than titanium. So we are replacing the steel with the titanium. And titaniums are used in cockpit frames, compressor disc due to their high strength to weight ratio, corrosion resistance, and thermal tolerance, enhancing fuel efficiency and durability. As I already said, when we are started to reduce the weight of the plane, it will started to save our fuel and increase our efficiency. Nickel-based superalloys. The commonly used nickel-based alloys are Inconel 718, Rene 41, Espla alloy are used in superior performance in an extreme thermal environments. Nickel-based alloys are chosen where the temperature is going to be a higher one, because nickel in the matrix of microstructure of nickel alloys, Inconels are very greater to withstand the higher temperature. Uh, The key aerospace applications: essential in turbine blades, combustor liners, and the exhaust system of jet engines where a sustained high temperature strength and oxidation resistance are required. Material nickel advantages of nickel-based superalloys for aerospace is exhibiting outstanding creep resistance and maintain a mechanical integrity beyond 1000 degrees Celsius, making them indispensable in propulsion systems. Uh, the creep resistance, a new term I have introduced here. Creep is defined as an deformation on higher temperature. For in 1000 degrees Celsius, the deformation of a nickel-based superalloy is very less compared to the steel. That's why it is used in propulsion system. Propulsion, as all know, propulsion system is the main part of an ignition of an airplane. This image shows about the distribution of titanium and nickel-based superalloys on an aero engine. For an fan and other important parts which where the temperature will be higher, the nickel-based alloys are used. Magnesium alloys. The commonly used magnesium alloys are AZ31B, ZE41, where the weight should be reduced. Magnesium is also one of the low weight high strength material. And key aerospace applications are used in non-critical components like as housings, interior brackets, gearbox casings, where mass reduction is prioritized. Material advantage, magnesium alloy advantage for aerospace are lightest structural metals offering excellent machinability and vibration damping properties. Then high strength steels in aerospace. High strength steels offers an excellent vibration resistance. The steels like 4340, 15 pH, and 828, these are the magnetic steels used in aerospace industries to increase the fatigue life under the dynamic loads. Uh, due to their high strength, it withstands the fatigue load and cyclic loads on that particular area. Key aerospace applications are: it is used in landing gear components, actuators, engine shaft, and structural fasteners. The fasteners are made with 828, 8286, and 4140. This like an eye alloy steels and eye strength steels. Smartness material advantages. This provides a excellent harness wear resistance for this after the heat treatment process. Heat treatment plays a crucial role in that high strength steels alloys. When while we are heat treating the materials, it has enhanced the durability, hardness, strength of the materials, which make them ideal for an vibration resistance locations. Copper alloys. Beryllium copper and copper nickel are employed in aerospace industry for their conductivity and fatigue strength. Key aerospace applications are utilized in electrical connectors, bushings, and wear resistance parts within avionics and actuation systems. Copper alloy advantages for aerospace. This provides excellent electrical conductivity and ideal for high cycle fatigue environments. The superalloys plays a vital role in the aerospace industries. It's like an nickel-based alloys where the higher temperature, sustaining for higher temperature is required. The superalloys are used in critical jet engine components such as turbine blades and compressor discs. Their higher temperature durability ensures engine efficiency and the reliability. With modern manufacturing techniques enabling complex and lightweight parts with the superalloys. As a summary of this, I have put a slide which describes all the materials and common grades used and key properties and typical use. For aluminium, it's 2024 and 70756061 are the common grades. The key properties are lightweight, strong, corrosion resistance. The typical uses are skin frames, internal structures. For titanium, the common use grade are TI6AL 4-4B. It gives an eye strength, heat and corrosion resistance, mainly used in engines, fasteners, airframes. For nickel alloys, the 718 for nickel alloys, Inconel 718 is used. It gives an excellent, excellent. It shows an excellent properties at higher temperature and creep resistant. Used in turbine parts for IH and steels. The major grades are A286. 8264340. It provides an high toughness and fatigue strength. It's used in landing gear shafts and bolts. Magnesium alloys are ultra lightweight and vibration damping. This used in casings, wheels, where the non-structural applications. For copper alloys are used in electrical and friction components. As a summary of the material selection criteria, the first thing is that it should be a lightweight. The primary thing while we are choosing a material for an aerospace application, it should be a lightweight. To increase the efficiency of a flight, the weight should be reduced, and then thermal and corrosion requirements. These are the two major important factors that deciding the materials for which we are going to be used in the aerospace. conclusion of the material selection is material should be enabling the safer and more efficient aerospace vehicles. Advanced aerospace materials such as aluminum, titanium alloys, along with the composites, provides an essential strength to weight ratios, corrosion resistant, enabling safer, lighter, more fuel efficient aircraft capable of carrying heavy payloads. And another point is continuous innovation driving aerospace performance. Ongoing research into the alloys, composites, and nanomaterials fuel aerospace advancement by enhancing the durability, thermal resistance, and environmental stability. The future trends of the aerospace materials are uh, in along with the composites are nanoparticles, graphene, and lightweight composite particles. Nanoparticles are why should be the future trend in this category because nanoparticles integrated into metal matrix significantly enhance the strength, thermal resistance, and electrical conductivity while maintaining the low weight and enabling lighter, more durable aerospace components. Same like graphene has an higher temperature resistance with the superior electrical conductivity, high tensile strength, making it an ideal for lightweight applications. Uh, and finally, composites material, which is grown up in these days, should be the will become the one of the inevitable part in the aerospace materials. As the conclusion, the however the composites are growing, but the seek for the metallic materials is not goes down. To replacing the metallic materials is quietly difficult, and for the in the research they are going to be used not not replace the metallic materials with the composite, but they are going to do one thing. What it is means to reduce the density and weight of the materials by replacing the other metallic materials, like from steel to it came to aluminum, then it came to titanium, titanium then magnesium, like that. The density of the whenever the density of the materials became less, the weight is also gonna to be the lesser one, that automatically efficiency fuel consumption will be good one. The fuel consumption will be less, and the efficiency will automatically increase. Uh, Thank you. This is the end of my presentation, and I have some samples for you, which are used in aerospace materials, which is confidential. But I am showing to you. This is the washer. It is visible, sir. Yeah, this is
Yes,
an
sir.
serrated in this is an serrated internal tooth lock washer. It is used in aircraft parts. It is a customized part. It's not belongs to any international standards. It is made with an customization. Uh, Now we are working on this part. This part we are gonna to develop this part for our nation. It's completely based on indigenization. It's an part which now it is important from the other nation. This is our product which we have developed, and other products are this wire lock net. Uh, this is tab washer used in aircraft parts to in an electrical lines. It's made up of CR sheet metal, and these parts are rivets, aluminum, made up of aluminum, used in aluminum. It's combined combinations of magnesium used in where it is the where low strength, high strength, low weight criteria is required. Thank you, sir. Thank you. Is there any queries?
Sir, good evening, sir.
Good evening.
Sir, I am Dr. Davamani. I am head of the Department of Aeronautical. I'm also Honorary Secretary of IEI Salem Local Center, sir. Actually,
Yeah, ma'am.
what is your service, sir? Only you are making the indigenous products to our defense.
Yeah, ma'am. We are in fastener manufacturer.
Mm.
We are a startup focused on
Oh,
indigenization, but not only indigenization. We are also providing
mm.
private sectors also, ma'am.
Okay, sir. Okay, sir. Very good. We are very much proud about the Salem. Already, Salem Aero Park is there, and one more company in our Salem making the defense products and aerospace products. Thank you very much, sir. If I need any help, I'll contact you, sir. Both.
Yeah, ma'am. Surely you can contact us. We are
Yes,
always
sir. Yes, sir. We
looking
need
to
your
develop the Salem
expert
and
talk to
develop the
our.
Salem, ma'am.
Yes, sir. We need your expert talk to our college, sir. So we will
Surely, ma'am.
invite you, sir. Yes, sir.
Surely, ma'am.
Good evening.
Thank you,
I
sir.
am Rajan.
Good
Hello.
evening, sir. Good evening, sir.
Good evening. And heartiest congratulations to Mr. Watson and Mr. Jairuban
Hi,
Hi,
sir.
sir.
for a wonderful, excellent talk. It's a new topic and highly interesting also. Very good. Only for you, we all know that for stainless steel, Salem steel plant is there. Similarly, for carbon steel, our JSW is there. For your suppliers, for your metal product, you need their support or duplex stainless steel or something, all are you are explaining. Just I want to know the main suppliers, aluminum, stainless steel, carbon steel, uh, uh, who will be supporting for your product other things.
Nataraj, sir, it's a
Yes, yes.
surprise for me.
After
Sir,
seeing the just I want to
surprise for me.
attend it to
சூப்பர் சார். சார் ஏதோ மிஸ்டேக்னா சொல்லியிருந்தேன், எங்களுக்கு அதுக்கப்புறம் கரெக்ட் பண்ணிடுங்க இன் அவர்
okay, okay,
ப்ரெசன்டேஷன்.
okay.
Sir, we have our 5 kg our own furnace, sir. From that we
Okay,
are
okay.
getting our aluminum. For Inconel, we are tied up with IIT Madras and IIT Delhi. From there we
Very
are
good, very
using
good.
titanium, sir. And for some product we are getting from the melting, some from 3D printing.
Good. As explained by Daumoni, really we are very much happy and proud that for aerospace industries you are coming up. Our artists, congratulations, best wishes. We will keep in touch.
Thank you,
Thank
sir.
you.
With your blessing we are growing, sir.
Okay.
Hello.
Anything?
Sir, Mr. Vasant Murugan, sir, and Mr. Jairuban, sir.
Yeah, sir.
I got one basic question from you, sir.
Yeah, sir, please.
The aeroplanes are while flying in high altitude, no?
Yeah, sir.
Some bats are hitting, and by that the planes engines are getting damaged and leading to some accident like that we are hearing in our
Yeah,
day-to-day life, you know.
yeah, sir.
For the engine, whether we have got any plan to design any high strength weld mesh like thing and assemble in front of that engine to avoid this sudden failure of engine and all. Whether anybody thought of in the working and designing in the aerospace industry, no? From the beginning, we are hearing this same problem repeatedly. High altitude, some bats are entering in the engine, and the engines are getting damaged and leading to major accident. You know, why we are not planning for any weld, high strength weld mesh like thing for placing in front of that engine? That is my doubt and question.
Sir, already there are, if I am not wrong, kindly correct me. There are 3 stage of productions are available in current planes and everything, sir. After that only it occurs. People are still working in that area, sir. Recently we got one article, platinum wires combination alloys are planning to be going to be retrofit for the meshes also, sir.
Thank you, sir. This I am getting in the doubt from the whenever I am seeing the aeroplane, no engines.
Yeah, sir. It's basically the four
All
six
the
happen,
engines
sir.
are kept open only without placing any mess like thing.
It's
Thank
still
you.
they
Thank
are
you for
focusing on.
some plan is there, but we have to take it up seriously, sir. That is why.
Okay, sir.
Thank you, sir. Sir, can you
Thank
spare
you.
your email ID and contact details, sir?
Sure, sir. I will provide in the.
And the basic presentation material also you can share for our members
Sure,
reference.
sir. I will give it to
Whatever
Thiago, sir. He will get.
that confidential things you need not spare, sir.
Okay, sir.
General things you can spare.
Okay, sir.
Thank you, sir.
Thank you, sir. Any more questions? Hello.
If there are any further questions, shall we get it concluded? Well, thank you, Engineer Jayarubhan sir, for a wonderful presentation on aerospace materials. Our knowledge have enlightened with your presentation. And now, as a note of conclusion, I would like to invite the Honorary Secretary, IEI Salem Local Center, to propose the vote of thanks. Ma'am, please.
Thank you, sir. Most respected our chief guest and keynote speakers, Engineer Vasant Murugan sir, Engineer K. Jairupan sir, respected Chairman Dr. K. Tangaraj sir, most respected state members, Dr. Arivudain MB sir, members from nation and the state, Dr. Arivudain MB sir, Dr. Nadarajan sir, council members, fellow engineers, students from various organizations, good evening to all. It's my great honor and privilege to deliver vote of thanks for today's enlightening seminar on aerospace materials. This is 84th special webinar under the aegis of ASDB. It gives me immense pleasure and honor to thank our esteemed speakers, Engineer Vasant Murugan sir, founder and CEO of Nita Aerospace Private Limited, Salem. Engineer K. Jairupan sir, Engineer Quality, Nita Aerospace Private Limited, Salem, for gracing this occasion with your presence. For sharing such an insightful perspective in this aerospace materials. Sir, your both valuable perspective on innovations, challenges, and emerging trends in aerospace materials have truly broadened our understanding and sparked engaging discussion, sir. Thank you so much for both of you. Our heartfelt thanks to our beloved chairman, Dr. K. Tangaraj sir, for his unwavering dedication and meticulous planning under leadership. We have successfully conducted numerous events at our IE student chapter, Salem Local Center. My sincere thanks goes to Arivudain MB sir, Nadarajan sir, and Karupasamy sir. I extend my sincere thanks to our engineer stock team members, Dr. Satish Kumar sir, Dr. Kumaravel sir, Arumugam sir, and K.S. Selvam sir for their support. It's my privilege to thank Engineer N. Arumugam sir for his engagement, for spent valuable time with us and efforts. Thank you, sir. I would like to appreciate Mr. Thiago for his dedication, which is highly commendable. Let us carry forward the knowledge gained today and continue to explore, the innovate, and collaborate in the aerospace realm of aerospace materials. Thank you once again to each and everyone present here. Thank you.
Thank you, sir.
Thank you, sir. Thank you, sir. Both of you, sir. Thank you so much.
Thank you, sir.
Vasant sir, thank you, sir. Thank you very much.
Thank you. Thank you, sir.
Jairupan sir, thank you.
Thank you, sir. Thank you, sir. Thank you for
Thank you, Abdullah.